problem what I think I given you as homework. You can just have a look. So only 3 constraints are there. So in the standard form, you have to add here plus S1 here, plus S2 here, and plus S3 here. So equals 10, equals 25, and equals 35. So your objective function will have plus 0 S1, plus 0 S2, plus 0 S3. So that's the way you can solve. Proceed further for your iteration. Okay, so it is shown over here. So you can prepare the table. So x1, x2, x3, you have the Cj values are here. Okay, Cj values are here. All the constraints are here. Okay, find the initial feasible solution. So entering into the space is all my slack variable. All the slack variables have a coefficient of 0. So that is written over here. Okay, so then we have to calculate Zj, and either Zj minus Cj or Cj minus Zj. So you will get here as if it is Cj minus Zj, you will get it as 8. If it is you have taken Zj minus Cj, you will get this as minus 8. So the entering variable you have selected x2. Okay, so x2 is your entering variable in the next iteration. So this is basically now your key column. So using the key column, you find the replacement ratio. So this will be 10 by 1. Okay, 10 by 1, 25 by 3, and 35 by 5. Okay, so you got the lowest positive over here as 7. So you have selected the key row. So the departing variable will be S3 in the first iteration. So that is the departing variable. Okay, so that is the departing variable. So the key row has been modified. You know the equation. The key row has been modified. Then the other rows are also being modified. Again, you can calculate the Cj minus Zj or Zj minus Cj. You can calculate. Okay, so you are seeing that here it is taken as Cj minus Zj, or both the case. So 22 by 5 is coming. So you are selecting the largest positive here. So largest positive, this is going to be your next key column. Okay, your next key column is marked. Then using this information and using your RHS of the equation, you can calculate the replacement ratio. The lowest positive is taken as your key row. So you will get the intersection of key row and key column as key number. You can again go for the next set of iteration. Okay, so again in the next set of iteration, you can again calculate Cj minus Zj. So you will be getting the positive as 2 by 7 since it is Cj minus Zj. So this is now your in the third iteration, that is now going to be your key column. Find the replacement ratio. So you can see that this is the 5 is the lowest value here. And somebody have asked me in the morning regarding infinity. So infinity is high positive, not low positive. So infinity if comes, you can ignore. 0 if it is coming, you have to consider. Okay, so 0 or positive, lowest positive you can consider. Infinity you can ignore it. Okay, so this is your key row. So you can go for the departing variable. Okay, so you can see over here now in this case. You can see that S3 is going to replace S1, not your X3. Okay, sorry, not your variable which is there in the problem. The problem is not optimized. That's why this iteration is going on. Okay, so you can see over here that the last case. So it has you will be getting in the third iteration. You can get the value. Yeah. Any doubts in this? So algorithm terminates with x1 value as 5, x2 as 5, and z as 70. I hope you all have got the same result. Okay, right. So if that is the case, I'll be going to the next set, minimization problems. Okay. So how to attack the minimization problem? Minimization problem, whenever it comes to you, yeah, convert that into a maximization problem and solve. Okay, we have seen so far solving a maximization problem only. Convert the objective function of the minimization problem into a maximization problem and solve. And finally, when you get the answer, you can see that is in the last column. You are getting over z as 70. Instead of z as 70, if you solve a minimization problem as a maximization problem, you will get the value as z as minus 70. So this is the only difference you will get when you are getting set as minus 70. That is maximization. You can convert into minimization as rupees 70. Okay, so that will be the only difference between a minimization problems. But when the constraints are going to vary, that is not the case. See, for example, yeah, you can see a problem over here. So minimize z equals 3x1 plus 4x2 subject to the constraints 2x1 plus 3x2 less than or equal, sorry, greater than or equal to 8, 5x1 plus 2x2 greater than or equal to 12, x1, x2 greater than or equal to 0. How will you tackle this problem?
Minus S1 minus S2 will give.
Yeah, okay, right. So a minimization problem, if it is greater than symbol, you can add simply plus S1 plus S2, and this objective function will be modified as maximization z equals minus 3x1 minus 4x2. Okay, now in the case of constraint, since it is greater than come, you have to subtract, okay, you have to subtract a variable called surplus variable, okay, subtract a variable called surplus variable. We will again mark it as S1, S2, S3, etc. Okay, so this if I convert it, it will come as 2x1 plus 3x2, okay, minus s1, okay, equals 8, and this equation will becomes 5x1 plus 2x2 minus s2, okay, equals 12. Okay, and your objective function will have minus s1 minus s2 will be continuing. But what is the issue here is? What is the issue here is? Yeah, I'll come to it. Hence, the problem changes into minimization. So, minimize z equals 3x1 plus 4x2 plus 0s1 plus 0s2 subject to the constraint. Yeah, so I have written it over the same way. x1, x2, s1, s2 greater than or equal to 0. Okay, now what is the condition? Now, what is the issue here? Now, what is
Coefficient
the
of S1
issue
is
here?
to negative, sir.
Yeah, both S1 and S2 are negative coefficients here. They are not positive coefficients here. So now how to tackle it? Okay,
Put
so you
S1
can
S2
see,
less than 0, sir.
yeah, no, you can't put like that. Okay, now you can see you are writing x1, x2, s1, s2 greater than or equal to 0, but your s1, s2 is having a negative coefficient. Okay, a negative coefficient. So what will you do or how to tackle it? So you can see surplus variable don't qualify for basic feasible solution because they will violate the constraints. Okay, and in order to start the simplex algorithm, we need to have a basic feasible solution. Now, this is if it comes like that, a greater than or equal to symbol, we need to add one more variable into the problem to make minus s1 as a positive coefficient, that is called artificial variable. Okay, so please understand that that is not because of your minimization constraint. It is because of your constraints is having greater than or equal to symbol. You need to add a new variable. One more variable also needs to be introduced into the problem, that is called artificial variable. That is you can see there are three types. The constraints can be of three types. One, it can be of less than or equal to symbol. If it is less than or equal to symbol, you need to add only slack variable. Okay, you need to only add slack variable. If it is greater than or equal to, then you need to add, you need to, okay. So if it is less than or equal to symbol, need only plus s1 comma s2 etc. Okay. If it is in the case of greater than equal to symbol, then it should be minus s1, minus s2, etc. And you have to add a new variable that is called artificial, that is called artificial variable. Artificial variable will be plus a1 comma plus a2 etc. Okay, and if your constraint is having a sign of equal to, you need to add plus a1 comma a2 etc. So this is a rule, this is the thumb, this is a minimized rule which you have to follow in all the standard conversions of the problem. Okay, it is not at all related to your objective function. It is related to your constraints. How your constraint is, accordingly you need to add. And the new variable what I am entering right now, that is called artificial variable. Okay, so that variable is called artificial. So this problem will become something like that. There is this equation will become something like as 2x1 plus 3x2 minus s1 plus a1 equals 8. And next one, it will be 5x1 plus 2x2 minus s2 plus a2 equals 12. And objective function will modify as plus a1 plus a2. And here also non-negativity also you can write x1 comma x2 comma s1 comma s2 comma a1 comma a2 greater than or equal to 0. So this plus s minus s1 plus a1, okay, will be a positive value. That is the assumption what we are following. So this will be a positive, so that the effect of minus s1 will be nullified by this new variable whatever we are introducing called as artificial variable. Okay, that is why the new variable we are introducing, this is called artificial variable. So artificial variable, if it is coming into the case of your simplex model, there are two approaches for problem solving is there. One is called Big M method. Okay, Big M method, and the next one is called two-phase method. Okay, the next one is called two-phase method. So the choice will be always here to go for Big M or two-phase. Nowhere in the question the methodology, what methodology you have to follow will not be mentioned. If you are comfortable with Big M, you can go for Big M. If you are comfortable with two-phase, you can go for two-phase. But the procedure in which both the problems are solving are different. Okay, is that clear? Is that up to this? Is it clear?
Yes, sir.
Yeah, okay. So this is what already we have discussed. So you can see over here, this I am going to attempt by using Big M method.
Sir,
Yes, please.
sir, even after introducing artificial variables, the still coefficient of that S1 and S2 will be negative, no, sir?
Yeah, that will be negative, but put together this new terms, whatever I am adding, that will becomes as positive. So that is my assumption.
Okay, sir.
Okay.
Yes,
Sir,
sir.
one doubt, sir.
That is my. Yes, please.
Sir, we can square on both sides, you'll get positive, no, sir?
Which one?
No, no, nothing, sir. Nothing, sir. Okay.
If we square, okay, if we square it, then your functionality will change.
Oh, okay, sir. Because then we can take that S1 squares coefficient and do the simplex method itself. No?
Pardon me?
Like if we square, we can square it and make it positive. But it will have two minimums or two maximums if we do like that. Then like we can use simplex method to find the like a normal method, right?
Uh, that was not seen. Anyhow, you can try later.
Yes.
Okay. Okay. So this problem we will be solving with the help of Big M method. Okay. So what we are giving is that the value for a in your objective function will be marked as m. Okay, will be marked as m. So m will be a very large positive value. Okay. So m will be a very large positive value, okay, which tends to infinity. Okay, and first we have to ensure that the optimum solution does not have these variables as a part of the solution. That is a1, a2 are not part of the problem. Okay, that is why they are called as, so no clear definition, no physical meaning. They are, that's why they are called as artificial variable. So a form a problem I am converting like this. Okay, like this in the case of bigger method. That is the constraint. I have added the artificial variable accordingly a1 and a2, and in the objective function the a1 is added as ma1 and ma2. M is a large positive integer value. Okay, large positive integer value. so that the net effect will become positive. So that is what is the basic objective is. Once you convert this, you can employ the simplex method, the same methodology whatever we have seen so far, you can employ here. Okay, now what will be the next step? When the step one is to convert into standard form. Okay, so the step one, convert into standard form. So that is already done here. What is step two? What is step two? What is step two? Step two is to find initial solution. Am I right? Hello?
Yes, sir.
Yeah. The step two is to find the initial solution. So how will you find the initial solution here? How will you find the initial solution here?
X1 and X2 equal to 0.
But here you can see you have two more sets of variables are there, A1 and A2. So which of
S1
this?
also we can put 0.
Yeah, so which of this you have to give the priority? So the priority as is told over here, A1, A2 are not part of the problem. So whatever is not part of the problem, you need to remove from your solution space at the earliest. So first you have to give the uh, first you have to give this here in this case you can say x1 comma x2 comma s1 comma s2 equals 0. Okay, so the variables whatever is entering first into your solution space will be artificial variable. Okay, so that will be artificial variable. So if artificial variable is present in any of the constraint, that will have the first priority. Okay, that will have the first priority to get eliminated. Then followed by slack or surplus variable. So this is you have to keep in your mind when you are solving the further problems. When artificial variables are present in your problem, first it has to get eliminated. Then you have to eliminate the slack or the surplus variable. Okay, so that is how you have to solve the problem.
Sir, that X1, X2, X3, X4, X3 and X4 not there, no?
Which one?
In that subject to equation X1, X2,
Yeah,
X3 and X4. X3, X4 where, sir?
not X3, S4, S1, S2. Sorry,
Okay.
I have written here. Are you? Is my writing is not visible to you?
Okay, sir. Visible, it's visible, sir. Okay, sorry, sir.
Yeah.
I meant the other one, sir. Right.
Yeah.
To left.
And I just want to inform you also that in that some foreign other textbooks, this S1, S2, A1, A2, they will all mark continuously with X only. Okay. So if X1, X2 is there, the next variable they will mark as X3. This will be X4. A1 will be X5 and A2 will be X6. That's the way they will solve also. Okay. So just to differentiate all those things, we are following the different conventions for you to easily identify it. Okay. So okay. So now the same way I have converted are okay. So the Cj values are written here. So your objective function is written here. Okay. Your constraints coefficients will be written over here. Okay. Entering variable as a1 and a2. So a1 having a coefficient of -m and a2 is having a coefficient of -m. So that is written here. RHS of the equation is written over here. So please calculate and let me know what is Zj minus Cj or Cj minus Zj value. So equation is given. Okay, so I can add one more column also in the down. So Zj.
Sir, could you go to the previous slide once again, sir?
This one?
The previous one, sir, before this.
This one?
Yes, sir. Okay, sir. Now got it, sir.
Okay. So minus 2m. Okay, minus 2m plus minus 5m. How much?
-7.
Yeah. So Zj will be minus 7m.
No. Oh, yes, sir. Yes, yes.
Here it will be minus 5m. Here it will be m. Am I right? Here it will be.
Is the value of Zj, no, sir?
Yeah. Yes.
Okay.
Yes. Here it will be minus. Sorry. Here also it will be m. Here it will be minus m. Here it will be minus m. So if you are going for Zj minus Cj, it will be minus 7m minus of minus 3. So minus 7m plus 3. So this will be minus 5m plus 4. Here it will be m. Here it will be m. Okay. What will be the next one?
-2m. No, 0.
0
0.
and 0. Yeah. Can you see to it? So this is Cj minus Zj. I have gone for Zj minus Cj in the previous slide. Okay. So now which will be my key column? Which will be my key column?
-7m plus 3. First one.
Yeah. Yes, exactly. So that will be my key column. So you can find the replacement ratio. So replacement ratio will be 8 by 2 and 12 by 5. 8 is here in the RHS side and 2 is here, 12 is here and 5 is here. So 8 by 2 is 4 and 12 by 5 is how much? 12 by 5 is how much?
2.4, sir.
0.4. Okay, right. So now which will be the key row? Which will be the
Minus and
key
A2.
row?
A2, sir.
A2, yeah. So 2.4. So the entering variable will be x1. So x1 is your entering variable and A2 will be your departing variable. Yeah, so you can see. So now go for the next iteration. Was there clear or any doubt in that? Is the things are clear or any doubt in this? Is this clear or any doubt in this?
No, sir.
Okay. So next iteration you can see A2 is replaced by x1 and 3. You can reduce the equation. Okay. Please solve. Please solve. Please solve and please get me the results.
Can you show the how to replace, sir?
Pardon me?
Okay, instead of A2 we replace x1. Okay.
Yeah. Instead of A2 we replace x1. That is what we have got it from the previous results. Yeah, here you can see. And 12 by 5. So this will be the key number. So first divide all the element, that is 5 by 5, 2 by 5, 0 by 5, minus 1 by 5, 0 by 5 and 1 by 5 and 12 by 5 in this the new equation. Okay, then old element, yeah, so old element is already here. So 2 minus intersecting element is 5. Okay, so 2 minus 5 into 1. These values I have a doubt. Value is wrong. What will be the value? It is 2 minus 5 into 1. Yeah. How did I taken this value earlier? Is this 0 here?
Yeah.
Yes, sir. There's 0 only, sir.
Sorry. 2 minus 2 into 1. Yeah, right. Sorry. Okay. So 2 minus 2 into 1. Yeah, sorry. 2 minus 2 into 1. Okay. So here it will be 3 minus 2 into 2 by 5. If anyone is having any doubt, I am just calculating it. Okay. So here it will be minus 1 minus 2 into 0. So here it will be 0 minus 2 into minus 1 by 5. And here it will be 1 minus 2 into 0. And here it will be 0 minus 2 into 1 by 5.
Sir, one doubt.
And
2
here
into
we-
come from where, sir?
2
2 into which coefficient you took? 2 into 2 minus 2 into 1. That 2 where it come from? The 2.
2 this 2 you are asking, or this
Yes,
2
sir.
you are asking?
The inside the
First
bracket.
2,
Inside the
yeah,
bracket.
so inside the bracket, yeah. So first 2 is the old element in
Yeah,
the
old.
column.
Yes, sir.
Okay, everywhere. Okay.
Okay.
Second 2, which column we have considered as the key column?
Okay.
The
first one,
first
next one.
column.
Next one.
The
Yes, sir.
first column. So corresponding element in that column. Okay. Corresponding element in that column. That 2 remains constant everywhere in that column. If I had one more constraint over there, whatever that element, that will be into this changed element.
So if it is the second column, if you're getting as the key column, then we might take as 3, right?
If you are getting, yeah, yes, exactly.
Okay.
Correct. And here also it will be 8 minus 2 into 12 by 5. So here we are directly calculating it. So it is something like 5 by 5. This is the first key row you have to reduce with the help of key number. The intersection row and column element, that is called the key number. We have to reduce first the key row by dividing the key number continuously with all the elements in that row. That is how you are getting these values as 5 in the denominator everywhere.
Okay.
Still anyone is not clear or any doubts?
No, sir.
Yeah. Then calculate for Zj minus Cj or Cj minus Zj. Okay. Now what's the situation?
11m by 5, that will take as key column.
Yeah. So next, this will be your key column. So find the replacement ratio. So 16 by 5 divided by 5 and 12 by 5 divided by 2 by 5. So 16 by 11 and 12 by 2 will come.
1.45. 16 by 11 will get.
Yeah, so you'll get, so you can see to it, this is going to be the key row. So you can see x2 now is going to replace, so this is x2. So in the next iteration, x2 will replace a1 in the next iteration. So this will be the entering variable and this will be the departing variable. So draw the line again and continue for the next iteration. So x1 is already there, x2 is there. So x2 coefficient is minus 4. So that minus 4 is entered into the solution space right now. Minus 3x1 already exists over there. Now this is your key row and key number you are getting as 11 by 5. So this will be 0 divided by 11 by 5. Okay. 0 by 11 by 5. So this is 11 by 5 divided by 11 by 5. This is minus 1 divided by 11 by 5. Likewise, it will be continuing. And in the same way, what I have told you in the previous case. So, you can get the equation. Again, calculate Zj, calculate Zj minus Cj. Yeah.
After this, if it is not optimized, what will you do? What will you replace?
Again, whatever is asking you to replace, you have to do it. Previous problem, the homework problem what I have given to you, you can see S2 is replacing S3. You are going for one more iteration.
That we have three this thing. Here only we finished both, no sir. So after x1 and x2, we'll say if it is x1.
Sometimes this S1 or S2 may get replaced over here, one of the variable, indicating that two of these products you don't need to manufacture, you need to manufacture only one. Or two products you don't need to buy, you need to buy only one product.
Okay, sir. Okay.
Clear?
Yes, sir.
Yeah. So, is the end of the solution? Is this the end of the solution? Is the problem terminates here?
Yes, sir.
Why?
Because x1 and x2 we are getting 0 values.
Okay. You see, please don't say that x1 and x2 are 0. You have to see all Zj minus Cj up to this RHS function. Okay.
We should continue. No, sir. Should they get a positive value or 0 rate? Should get a positive value or 0?
Positive value or 0 on what condition?
Positive value or 0 for
yes.
We should get for S1 and S2 also, because here the variable we are not considering is A1 and A2.
Yes.
So for we should continue the iteration until S1 and S2 also becomes 0 or greater than 0.
No. You see the condition here. You are talking about Zj minus Cj. Here it is a vice versa is taken. Okay. So this is the end of your iteration, and your x1 value will be 16 by 11. Okay. So you can see directly from the results here, 16 by 11 is your x1 coefficient. 20 by 11 will be your x2 coefficient. And why this minus 124 by 11? Why this minus 124 by 11? It is maximum Z. Okay. So therefore, minimum Z equals plus 124 by 11. And this will come as some fraction. You can approximately convert into next complete integer.
Sir,
Okay.
sir, a small query, sir. Sir, like last classes, you told that when we are getting, if you are getting any negative value for Zj minus Cj, then only you have to proceed to the next iteration, no, sir. So given given this table, for the last iteration, we are getting both x1 and x2 to be 0, no, sir. But you told that quoting x1 and x2 to be 0, that is not the proper reasoning for termination, no, sir.
Okay.
Yes, sir.
I'm not clear.
No. The thing is, like when you ask the question, can we terminate this table or not? Like I told that x1 and x2 are coming 0, so we could terminate this table. But actually, you told that that won't be the proper. That's not the proper reason, sir. Could you just repeat what is the correct reason, sir? We are terminating this table.
We are terminating.
Yes, sir.
What is the condition of x1, x2, s1, s2, a1, and a2 over here? Okay. Does any
Yes,
of the positive terms exist over here? Does any positive term exist here?
No, sir.
Okay.
Right from S1 to SK2.
Yeah, in that previous problem, when we are solving, one of the term exists as positive. I think I have shown it here.
Yes, sir.
In this problem, am I right?
Yes, sir. Yes, sir.
Which problem? Let me check. One minute. So in this problem, so yeah, 3 constraints. Okay. Do you remember which iteration did I told? So
last problem, the previous problem, second iteration, sir. So third iteration, problem 2. This was our homework question, sir.
Okay. Here.
Yes, sir.
Yeah.
Sir, yes, sir. Even this in this problem, like we are getting actually -3, -1. That's but we are terminating because we are searching for that maximum case, no, sir.
Yes, we are searching for see in this last column. So in this last row, there is no positive values here. Okay, there is no positive here. That is the reason why we are terminating.
Okay.
Okay, there is no positive here. So that is why we are terminating. If any one of this is positive, even you have x1, x2 over here, you need to go for the iteration. That is what you can observe here. So here the initially x2 entered into the problem. Okay, the x2 entered into your problem. You have s1, s2. You solve it. Okay, so you find the row. You find x1 will be the next variable. Okay.
Okay,
Yeah,
sir.
here you can see. So x1, x2 is entered. You solve it. You have calculated Cj, but Cj you can see you have a 2/7 exist over here as positive. Though you got x1 and x2, x1 and x2 are only the 2 variables in the problem. You have solved, you have got a value. But Cj minus Zj is not fully negative or 0. You have a positive value still exists over here. So you again continue the iteration. Here you can see S3 is replacing S1. Am I right?
Yes, sir.
Yeah, and with this, it will get, you can see all the things are either 0 or positive. You see. So we are terminating it. Still confused?
So, sir, the conclusion is until we get the positive value for Cj minus Zj, we have to continue the iteration.
See, 2 cases. Either you can go for, if you are calculating Zj minus Cj, okay, negative value indicates better opportunity. Okay, so you have to go for the next iteration. Okay, if you are calculating the vice versa, Cj minus Zj, okay, then positive value indicates better opportunity. Then you can go for iteration. Okay, and the termination will come only when, okay, in the first case you can see negative value, so there should not be no negative at all. Okay, no negative.
Okay, sir.
No negative value. If any negative value appears over there, you have to go for next iteration. In Cj minus Zj, no positive value. Okay, if any positive value exists in x1 or x2 or s1, s2, a1 or a2, you have to go for next iteration. Okay, so
Yes, sir. Got it, sir.
either positive or zero, you have to continue your iteration.
Oh, now got it, sir.
Clear?
Yes, sir. Clear, sir. Thank you, sir.
Yeah, it's okay, no issues. So we are yeah. So we have calculated here, we got the result 16 by 11 for x2, x1 is 20 by 11 and minus 124 by 11 for maximization set. We have calculated the minimization set as 124 by 11. I hope for all. So we have terminated the problem and we find the solution. Is that clear or any doubt still exists? Any doubt is still there? Any doubt?
No, sir.
Sir, could you share this PPT with us in that group, sir?
Sure. Today I will do.
Yeah, thank you, sir.
Yeah. So I'm just writing a problem over here. You can try. Minimize z equals 20x plus 10y subject to the constraints x plus 2y less than or equal to 40, 4x plus 3y greater than or equal to 60, 3x plus y greater than or equal to 30, x comma y greater than or equal to 0. Only one problem, you can take it as your homework.